Hello. Now something is missing, right? We need to do something to make the classification right. We have been extracting features very good using convolutions, as I said, with number of filters, and also using pooling. Now we need to use these features that we extracted and feed them into what we call a fully connected layer. This fully connected layer is going to learn the difference. It's going to learn to do the classification, also using parameters. We call those parameters weights. So here's what happens. It learns the parameters, the weights. If you add more images, so the program tries different parameters, sees how that performs, and starts optimizing those parameters using optimizers to get the best possible results it can do. And then if it learns some, it learns some parameters, and it uses these parameters for any image you input after that, right? Now, actually, we need to discuss how this works in Keras. In Keras, you do the following. You take the resulting array, which is probably, for most cases, going to be a 3D large array, because we have number of filters, So it's a bunch of 2D arrays stacked together, some 2D arrays stacked together for most applications. And then you take these 2D arrays stacked together, you flatten them using the flatten layer in Keras. What is that? It simply turns it into a 1D array. It's very simple, like the following. So it just takes the numbers in the 3D array and puts them in a 1D array. It does nothing, literally. It learns no parameters, very simple. And then feed it to the dense layer, which is going to do the classification. It's just some dense neurons connected together. That is why we call them fully connected layer. And it learns using the weights to do the classification. Actually, I want to say something. If it was just a binary classification problem like cats versus dogs, just two classes, two possible things, we can use. So we need the output of dimensionality to be 1 or sometimes 2. How? Look, if it was 1, the dense layer is going to output an array that have only one element. So for example, in this array, maybe 0 corresponds to cat and 1 corresponds to dog, right? And actually, also, you might even use two numbers. Only for binary classification, you use two numbers, not one number. Each one corresponds to some class. So for example, here, this first element corresponds to cat, the second element corresponds to dog, and sometimes on those two elements, you get the probability of it being something, of it being cat here and dog here. So for example, here 0.25 and 0.75. So 75% probability that this is a dog, right? Now, if it was with more classes, the dataset with more classes, you want more classes, for example, cats and dogs and humans, for example, here, you see, you can make it 3 numbers, an array of 3 numbers. First one corresponds for the cats, and then the dogs, and then the human. You can make it also with probabilities, all with probabilities, like this, 0.04, 0.9, 0.06, alright? So, that's it. Have a good day.